All right, let's get right into it. A new AI architecture has just popped up, and this one's different. It doesn't just process information, it seems to actually think, using time, memory, and making its own internal decisions. This could honestly change, well, everything about how we build intelligent machines.
For the better part of a decade, the entire AI revolution has been running on one single engine, the Transformer. Every big name you've heard of, GPT, Gemini, you name it, it all goes back to this one design from 2017. It's been the undisputed king, no question.
But here's where things get really interesting. Today's AI is kind of like a super fast calculator. You give it a problem, it runs through a fixed number of steps, boom, instant answer. This new idea, it's a completely different beast. It's an AI that can actually pause, deliberate, and decide for itself how much mental energy a problem is really worth.
So what happens when the very people who built the dominant technology turn around and say, hey, you know that thing we made? We think we have a better idea now. It's the classic disruptor story, but with this incredible twist. The inventors are disrupting themselves.
Okay, so to really get why this new approach is such a potential game changer, we first have to understand the power and the hidden problems of the model that has defined this whole era of AI, the Transformer.
The Transformer's genius, right, was its ability to process entire chunks of data, images, sentences, all at once, in parallel. That's what unlocked the insane training speeds and massive scale of models like GPT-4. But, and this is a big but, its greatest strength is also its Achilles heel. It uses a fixed amount of computation for every single task. A simple question gets the same brain power as a complex one. It literally has no way to think harder when it needs to.
And that weakness brings us directly to the challenger, a new concept born right from the limitations of the old guard. It's called the Continuous Thought Machine, or CTM for short.
The company behind this is Sakana AI, and you have to pay attention to who the founders are. Leon Jones and David Ha. These aren't just some random AI researchers. These were top scientists at Google. And here's the kicker. They were co-authors on the original Attention is All You Need paper. Yeah, the one that created the Transformer. They literally built the kingdom everyone else is living in.
This quote just nails it. The whole point is that this new model has agency. It has control over its own thought process. It can dynamically change how much computational effort it uses depending on the problem it's facing. That's a massive departure from the rigid, one-size-fits-all world of Transformers.
So how on earth does this actually work? How can an AI decide to think longer? Well, it all comes down to three key ideas: time, memory, and this neat little concept called tics.
A continuous thought machine, a CTM, is an architecture where the individual neurons, the basic building blocks, behave very differently. Each tiny neuron has its own little short-term memory, and it runs on an internal clock. Over a series of these tics, each neuron basically decides for itself, is it my turn to fire, or should I stay quiet for a bit?
This whole process builds up into a really unique kind of thinking. A prompt comes in, and the neurons don't all just fire at once. Instead, with each tick of that internal clock, they check their memory and decide if it's the right moment to contribute. If the problem is easy, an answer might form in just a few ticks. But if it's a real head-scratcher, the model and just let the clock keep running, allowing for more deliberation, a deeper thought process, before it gives you an answer.
The best analogy is to think of a factory. A transformer is that fixed speed assembly line. Every single task gets the exact same amount of work, period. Doesn't matter if it's simple or complex. A CTM, though, that's like a master craft person. They can work quickly on the simple stuff, but when they get to the intricate, difficult details, they pause, they measure, and they spend real time and effort to get it right.
Okay, so this all sounds great in theory, but what does it actually look like when the rubber meets the road? Well, early experiments are already showing some really fascinating, almost uncanny behaviors that suggest this is much more than just an academic idea.
For instance, when they gave it images of human faces to analyze, its attention didn't just spread out evenly. Over its internal tics, it first focused intensely on the eyes. Then, its attention organically shifted to the nose, and then the mouth. Which is crazy, right?
That's incredibly similar to how our own vision and brain work, suggesting the model is developing a more natural, step-by-step way of reasoning.
Here's another amazing property that just sort of emerged. It's called calibration. Because a CTM averages its predictions over multiple ticks, its stated confidence level naturally ends up being incredibly close to its actual accuracy. So if the model says it's 90% sure, it's actually right about 90% of the time. Now think about what that means for safety and reliability in fields like medicine or self-driving cars. That is a huge deal. Now, let's be real. If you look at traditional benchmarks like image classification, CTMs aren't yet beating the top-performing, super-optimized transformers, and that's okay. They weren't really designed to win that specific race. What's remarkable is that this completely new architecture is already in the same ballpark. It's actually excelling at tasks that transformers struggle with, like generating step-by-step directions from a raw image without any special guidance.
But of course, this is very early-stage tech, and it's not a simple path forward. There are some significant hurdles to overcome, and it's important to look at those with a healthy dose of reality.
Yeah, it hasn't all been smooth sailing. In an early release, a Sakana tool posted some incredible scores. But it turned out it was kind of gaming the system, exploiting a flaw in the test itself, not through genuine smarts. To their credit, the company was totally transparent. They acknowledged the error right away, updated their research, and tightened their protocols. It's a classic reminder of that tension between innovating fast and the need for rigorous, careful testing.
And on top of that, there are some fundamental technical challenges. Training a model with this kind of dynamic behavior is really tricky to get right. The whole ecosystem of AI tools we use today, it isn't built for this tick-based world. And ironically, allowing a model to think longer can actually add overhead that makes it slower on simple tasks. These are the big engineering problems that have to be solved for CTMs to really scale up.
So, what does this all mean for the future of AI? Well, the rise of CTMs really feels like a fork in the road. It's kicking off a fundamental debate about the best way to get to more powerful artificial intelligence.
On one side, you have the scale philosophy, championed by the giants like OpenAI and Google. Their bet is simple. Just make existing transformer models bigger and throw more data at them, and eventually they'll get smart enough. But on the other side, you've got this new adaptive philosophy from Sakana AI. They're arguing we should build smaller, more efficient models inspired by biology that actually learn how to think, not just how to pattern match from a giant pile of data.
And that leaves us with the big question for the next era of AI. Is the next great leap going to come from sheer size, from just building a bigger engine? Or is it going to come from designing an entirely new one? The continuous thought machine might not be the final answer, but it has already shifted the conversation. We're not just talking about how big our models are anymore. We're starting to ask how well they think.